Fibromyalgia is a chronic functional neurosensory disorder characterized by widespread musculoskeletal pain, fatigue, poor sleep, and tenderness in localized areas. It is more common in women than men and often occurs in individuals between the ages of 30 and 50, although it can occur at any age. The exact cause of fibromyalgia is unknown, but it is believed to involve a combination of genetics, autoimmune, environmental triggers, and psychological factors. Treatment for fibromyalgia include a combination of medications, lifestyle changes, and self-care strategies. Medications commonly used to manage symptoms include pain relievers, antidepressants, and anti-seizure drugs. Lifestyle modifications such as stress reduction, regular exercise, and good sleep hygiene can also manage symptoms. It is important to note that fibromyalgia can affect individuals differently, and what works for one person may not work for another. Therefore, a personalized treatment plan with your healthcare provider is essential. Welcome back to another episode of Polyamide Club's Ask Dr. Paul. Today we're going to highlight sustainable concepts. So when your boss talks about biomimicry with polymers, what do you need to know? Biomimicry is an innovative design principle that draws inspiration from nature's time-tested patterns and strategies to solve human design challenges. It is a way of looking at nature as a model, mentor, and measure for our own creations. The relationship between bioutilization, biomorphism, and biomimicry reminds me of the relationship between materials, processing, and design as shown on your screen. Biomimicry intersects with bioutilization, which involves the direct use of natural materials in human-made products, and great examples are wood, furniture, and stone. Bioutilization is a type of material selection just specific to natural materials. Examples of bioutilization of bioplastics and biopolymers include starch and cellulose, which come from plants and trees and are used to make disposable food service products like cutlery and clothing. Biomimicry intersects with biomorphism, which focuses on creation of products that mimic biological forms, which reminds me of polymer processing, like when a leopard or cheetah print shirt is processed and looks like nature. Further natural looks representing biomorphisms are shown on your screen. Biomimicry has many examples of designs that function like nature, including the structure of bird wings being used to design airplane wings, and the dolphin's tail fin or fluke being used to design swimming flippers. And the most famous plastic example of biomimicry or design that functions like nature is, of course, with the tiny hooks on Burr Fruit seeds, which inspired the creation of Velcro, in which PET or polyamide hooks attach to their corresponding fibers, like Burr Fruit seeds attached to your socks and pants during a walk in the wilderness. We can also think about the design of polymer materials and how similar the structures of proteins and polyamides are, because a peptide bond has a similar chemistry to a nylon repeat unit. Even their sizes can be similar, with Ribisco, the most abundant enzyme on Earth, being made of about 500 amino acids and having a similar average chain length to polyamide plastics, knowing it is common for polymerization of about 500 monomer units on average for polyamide plastic chain length. I even think the concept of polymerization, or converting monomer to polymer, is really natural based, because I think of biomolecules and glucose being the monomer or building block of carbohydrates, and amino acids being the monomer for proteins. And the same logic can be used to describe the other biomolecules, lipids and nucleic acids, which also have consistent monomer building blocks. Biomimicry has led to the development of bioplastics, which are plastic materials derived from biological substances. For example, polybutylene succinate, or PBS, and polybutylene adipate terephthalate, or PBAT, are oil-based plastics that are compostable and thus called compostable plastics, and are used in trash bags and decompose like plants end of life. These plastics demonstrate how biomimicry can contribute to sustainability by reducing reliance on non-renewable resources and improving end-of-life disposal goals. Also, PLA and PHAs are plant-based bioplastics, making them renewable with favorable end-of-life solutions and are called compostable bioplastics, which are used in the disposable food service industry. The relationship between bioutilization, biomorphism, and biomimicry is a spectrum of how nature can inspire and be integrated into human innovation, from the conceptual design stage to the actual materials we use. Just like materials, processing, and design, and we can add testing because the knowledge or polymer breadth is so important when producing robust polymer-based consumer goods. Knowing about biomimicry with polymers, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. You can visit our website to learn more about our upcoming Sustainable Polymers course. I'm Paul Nash for Polymer E Club's Ask Dr. Paul. Thanks for watching.